Hello everyone, I am Monika Bhushan and today we are starting lecture number 10 of linear algebra. In today's class, we are going to find the rank of a matrix by reducing the matrix to the normal form. Okay, since two classes we are finding the rank of a matrix, but the method which we have discussed was to convert the matrix into the echelon form. Correct? No, we have covered REF form and we have covered our REF form in our lecture number 7. Fine. But in today's class, the method which we are going to use is what? We are going to reduce the matrix into RREF form or normal form or canonical form. Okay, fine. So we have covered this complete concept in lecture number 7. So today's class we are not going to again discuss the theory behind normal form and all. We are directly going to jump to the question. So I will suggest you to brush up the concept through lecture number 7 and then it will be easier to understand the question. Fine. We have seen that these four forms are nothing but the normal form. We are going to reduce the matrix into one of these four forms and then we are going to count total number of non-zero rows. Okay, and that will only be called as the rank of the matrix. Fine. So here are the two questions which we are going to solve today. Find the rank of the matrices by reducing them to the normal form. That means again we are going to cover two steps, right? Step number 1 is what? We are going to reduce the matrix into the normal form, and step number 2 is what? Just count total number of non-zero rows. Fine. And that will nothing but the rank of the matrix. So this is the question. So now since we have to reduce the matrix into the normal form, then if you remember what we have covered in normal form, to convert the matrix into normal form, first we are going to convert the matrix into the echelon form, right? First we are going to convert the matrix into REF form, right? Fine. And converting the matrix into REF form, we're going to use only the row transformation. And this is very important, that convert the matrix into REF form by only row transformation. Okay. And the second step is what? Once you have reached into REF form, okay, then you have to apply the column transformation only. Then you don't have to apply any row transformation. So apply the column transformation to convert the matrix into normal form. Okay, so this much only we are going to do, and then we are going to count the total number of non-zero rows. So there are two sub steps which we are going to follow. So this is the first step and this is the second step. Okay, so that means till here we are only following the same thing which we have followed in lecture number 8 and lecture number 9, right? And only this much is extra to convert the matrix into the normal form. Okay, I hope the concept is clear. So right now what I'm going to do, my first focus is this number. Find no, the very first number of first row and first column, which should be 1, right? But this is minus 2. So what I should do, I'm going to interchange this row number 1 and row number 2 so that this 1 will be present here. Fine. So I won't have to do any calculation to have 1 here. Fine. So here is what I'm going to interchange row number 1 with row number 2. This much we have done. I'm not going to go into much detail. Since two classes we are seeing the same thing. Fine. So after that what I'm going to do, my focus is to have 0 at this place. Fine, no? Because 1 is present here. This is nothing but the leading 1. And as per the rule of row echelon form, all the numbers below leading 1 should be 0, right? And the same thing we are going to do here. So here I have to have 0. For that I am going to perform this operation. Here what I have done, 2 into R1. So 1 is present right now. So 2 into 1 and then plus R2. So 2 into 1, that is 2 minus 2 will become 0. Fine. And similarly the same operation I am going to perform at this place also, this place also and this place also. So I have got this much here. Okay. Fine. So here is my leading 1, here is 0. Now next focus is which one? Next focus is this number. I should have 0 here also. For that what I am going to do? Here is the operation which I am going to perform. This is what? Minus R1 plus R3. So minus R1 will be what? This is already 1, so minus 1 and then plus 1 will give you 0. So this is the benefit of having 1 at this place, okay? So you will be having very less calculation if you are using this leading 1 for the row operation, okay? So fine, so here also we have got, and the same operation I am performing in all these 4 places. Fine, no? Okay. Now already I have 0 present here. So row 4 is as it is. I have not changed anything because my focus is to have 0 and 0 is already present. Okay. So till now what has been done? This complete column is okay. Now which number is my next focus? Next focus is at this place. Why I am not considering this 2? Because as per the rule we have discussed that I am only interested in first non-zero number of any row to convert the matrix into the echelon form, right? Here I have to convert the matrix into the normal form only, but to reduce the matrix into normal form, first I have to convert the matrix into REF form, and then right, and this step only we are performing. Okay, so still I'm seeing that this matrix is not in REF form, so I will be keep on doing row transformation. Once I reach to the row echelon form, then I will stop there, right? So what I'm going to do here, so this place should be 1, okay? This place should be 1 because this is the first non-zero number of row number 2. Okay, I'm not interested on this number, I'm not interested in this number because this number can be anything as per the rule, but this first non-zero number should be 1. For that, what should I do? I can see that 1 is present here, right, and 0 is already there, so I can directly interchange row number 2 with row number 4 to avoid any calculation. So I have interchanged row number 2 and row number 4, so I got here 1 and 0 is as it is. Fine. So till here things are okay. After that I'm interested in which number? Since this number is what? This number is leading 1. Okay, no, this is my leading 1 for row number 2. So all numbers below leading 1 should be 0. Fine. So right now I'm going to deal with this number. This minus 2 should be 0. So one operation can come in your mind that this is 2, right? And this is minus 2. So what you can do? You can add these two things and you will get 0 here. Yes, you will get 0 here. But what about this place? This place will become 1 and that is also not allowed. So by practice you will come to know that which operation should I perform, and you are seeing this 1 is present here, so you can do the operation based on that row number 2, right? So R3 will be 2R2 plus R3. So we have performed this operation here and then we have got 0 at this place. I'm getting 0 here also, but I'm not worried about this number. This number can be anything. This number should be 0 and this number should be 0. Okay. Now what is my next goal? My next goal is what? To convert these 3 into 0. For that we have performed this operation. Okay. And then we have got 0, 0, 0 minus 2. Okay. Now, can I say that this is my REF form? Still, this is not in REF form. Why? Because I can see this row number 3. This row number 3 has first non-zero element which is 2, which is not 1. Fine, no? Similarly, in my R4, row number 4, the very first non-zero element is minus 2, which is not 1. So what should I do? So which operation I should perform? Basically, we want to avoid division operation, okay? But in this scenario, it is always better to use division operation. Why? Because if I'm going to perform R3 as R3 divided by 2, okay? So what will happen? This 0 by 2, 0 by 2, 0 by 2, 0 by 2. So here I am going to get straightforward 1. Fine. So here division operation is useful. Similarly, in my R4, I am going to do R4 divided by minus 2. So I am going to get 0, 0, 0, 1 in my R4. Why we want to avoid division operation? Because if somewhere it was 3 or 7, so 3 by 2, 7 by 2, so those fractional values we want to avoid. Fine, but here I can see that all zeros are there other than 2, so I'm just going to perform this division operation. Okay, till here if we have reached, I can see that here this is my leading 1, even this is my leading 1, that is first non-zero number is 1, first non-zero number is 1, first non-zero number is 1. That means this rule is exactly satisfying here. But I can see that below this leading 1 I should have 0, right? So what my goal is? My goal is at this position I should have 0. Okay, so for that, which operation I should perform? I can see that R3 and R4 both are same. So if I will just subtract R4 and R3, so it will give me 0. Fine, 0 minus 0, and then here 1 minus 1 is 0. Fine. Now, can I say that this is my REF form? So I just check that whether this is satisfying all criteria. If the matrix has 0 rows, it should be below all other rows. Yes, 0 row is present and this is below all other rows. Fine. And then below this leading one, all numbers are 0. Even this is leading one. Fine. No, this was leading one. This is leading one. I have all 0 present below this leading one. Can I say that this is my leading one? This is 1, but this is not leading 1. Fine, no, this is not leading 1. Why this is not leading 1? Because this 1 is present after this 1. Okay, in this row, this 1 is leading 1. Even if 1 is present, but this is not leading 1. So I am not worried about whether below this 1 I have 0 or not. Okay, eventually I have zeros here, but I could had 1 here also. That was also okay. Why? Because this is not leading one. I think this is clear to you. Fine. Similarly, this is not my leading one. Okay. And in this row, I can see that this is leading one. So if this is leading one, so below this leading one, I should have 0 and 0 is present. And all leading one are right hand side of previous leading ones. So all those criteria are getting satisfied, which we have covered in our lecture number 7. I can say that this is my REF form. Okay. Now what is my next goal? I have to reduce this matrix into normal form. Okay. The question is what they are asking us to first reduce the matrix into normal form and then you have to find the rank of the matrix. So my next goal is to reduce this matrix into normal form. Okay. So what we have said that till REF form. Okay. I have done only row transformations. Okay. But from REF to normal form, I am going to do only column transformation. This is very important. After that, you don't have to do row transformation. Okay. And we have not done any question on column transformation. So how to do this column transformation? So the way we were looking the matrix was in this horizontal way. Now we are going to see matrix into this vertical way. Okay, what does it mean? That means I'm going to now consider the matrix column wise. Okay, so in this column wise, what I'm going to do, I can see that this is my first column where this is the leading one, and after leading one, all numbers are 0. That is perfectly okay. Another thing is what? In my normal form of matrix, okay, in normal form of matrix, only zeros and ones are allowed. Okay, no any other number is allowed. I cannot have 2 here, I cannot have 3 here. I can have only zeros and ones in the normal form of any matrix, because what we have said that in normal form we have to consider the number which is above leading one also. Okay, so one more point I have to add in my normal form is what? That in my normal form the number which is above leading one, that also should be 0. Instead of 2 here I should have 0. Instead of 3 I should have 0. Now we are going to perform the column operation so that the matrix will be having only zeros and ones, and above leading one I will be having zeros only. Okay, fine. So I'm going to start with this column number 1. In this column number 1 I can see that the leading one is already present and below leading one all numbers are 0. So this is perfectly okay. Now what about my column number 2? Now my column number 2 is having 2 present here, and below that I can see that 1 is there, then 0 0. This 1 is basically leading one of this row. The second row has this number which is leading 1. So my rule says that above leading 1 I should have 0. So I am going to perform operation column wise so that this 2 will be 0. So how I'm going to do here? So for that, I'm going to perform which operation? I'm going to write down C2. Okay, instead of R2 or something, I'm going to write down C2. What is C2? This column. This column is C2. C2 is going to have what? I'm going to write down this minus 2 into C1 minus 2C1 plus C2. And why I'm doing so? Corresponding to this 2, I have 1 in my C1, right? So here will be minus 2 into C1. So C1 corresponding to this 2 is 1. So minus 2 into 1 plus C2. C2 right now is 2. So it is now minus 2 plus 2, nothing but 0. So now I will be having 0 present here. Okay, what about this place? So here it is what? I am going to write down here minus 2 into C1. C1 is 0, right? So any operation I am going to perform, it is going to give me 0 only. And then plus C2. So here C2 is what? 1. So this is nothing but 0 plus 1 is 1, right? So 1 will be as it is. Similarly, if I am going to perform here minus 2C1 plus C2, it is going to give me 0 only. Minus 2C1 plus C2 going to give me 0 only. Fine, no? Because both are 0 only. My equivalent matrix will have C2 as what? 0, 1, 0, 0. That only I wanted to have. Fine, no? What I wanted to have 0 at this position, above leading 1 and below leading 1, I should have 0, and that is happening. Similarly, for C3, what I am going to do here, this is my leading 1, this is my 3. So I can write down C3 as what? C3 as minus 3 into C1 and then plus C3. Fine. So that means what I am going to do here? This C3 is what? Minus 3 C1 plus C3. Similarly, for C4 also, C4 is having 1. So C4 will be what? Just minus C1 plus C4. So, and how I am understanding that I have to do this one? Because I should be having 0 present here. So, how 0 will happen? Minus 3 plus 3 will be 0. Similarly, 1 minus 1 will be 0 because column wise operation I am performing. Fine. After solving 2-3 questions, you will be comfortable with this column wise operation also. Fine. But whatever operation you are performing, you have to perform on each and every element present in the column. Okay. So same thing if you are doing for each and every element, okay, then you are going to get these many numbers. Fine. Okay, so now can I say that this is my normal form? So still this is not my normal form. Why? Because we have seen that normal form is what? Normal form will be in this fashion, right? If I'm going to write IR, that means identity matrix of order R. I hope you remember what is identity matrix. That means if I'm going to say my I2, that means identity matrix of order 2. Order 2 will be having what? 2 rows and 2 columns. Fine, because identity matrix is nothing but the square matrix. So if the diagonal will be 1, all other elements will be 0. So it will be called as I2. Fine. Similarly, what is my I3? I3 is what? Square matrix of 3 rows and 3 columns where the diagonal is having 1, all other elements are 0. This is nothing but I3. So, I am going to convert the matrix into identity matrix, okay, if the matrix is a square matrix. If the matrix is rectangular matrix, then it will be maybe zeros are present here, maybe zeros are present here. It all depends on how many rows and columns are present here. Okay, and cover this complete concept. So I'm not going to again go into this detail. Okay, so what I'm going to do here, I have got this matrix, but this is still not in my normal form. Why? Because the normal form should be having 1 in the diagonal place. But I am seeing that I have 1 here, 1 here, 1 here. In my normal form, only one non-zero element will be present in each and every row or each and every column, and that non-zero number will be 1 only. Other than this one, I will be having zeros only. Okay, that means what? If I'm having 1 here, so I cannot have again 1 here, I cannot have again 1 here. Okay, in each and every row, I will be having only one non-zero number, and that non-zero number will be 1. Okay, so what I have to do? I have to do some kind of column transformation so that at this place I will be having 0 and at this place I will be having 0. So for that, what I am doing? C3 as minus C2 plus C3. Okay, Why? Till C1 I don't have any problem. Till C2 I don't have any problem. In my C3 this 1 is not allowed because 1 is already present, so I cannot have another 1. So I have to convert it into 0. For that I am doing minus C2. This is your C2. So minus C2 plus C3. For this element that is okay right now. Why? Because minus C2 plus C3 if I am going to perform, this is your 0 only. Minus 0 plus 0 going to give you 0 only. What about this place? For this place it is what? Minus C2 minus 1 and then plus, right now I have 1. So it is going to give me 0. So now I will be having 0 at this place. And after that all 0 0, any operation you are going to perform, you are going to get 0 0 only. So you have got zeros here. Fine. Similarly, what I am going to do here, now this is your minus C2 plus C4. So minus C2 plus C4, that means minus 1 plus 1 going to give you 0. And similarly on this operation, this will be your minus 0 plus 1, it is going to give you 1, and this is 0 0 0 only. Okay, so my new equivalent matrix is ready here. Okay, can I say that this matrix is in my normal form? Because I can say that only zeros and ones are present, that is fine. And each and every row only one non-zero element is present, that is also 1. And here this is 0, that is okay, right? Because this is your 0 row. But still this is not in my normal form. And the reason is what? The reason is I can see that all zeros are present here. Fine. So how we have discussed in our REF form that if any zero row will be there, that zero row will be at the bottom of the matrix. Similarly, if I am having all zero column, okay, if the column is having all zero number, that should be at the rightmost side of your matrix. Okay. For that, what I'm going to perform? I'm going to interchange column 3 and column 4. Okay, so column 3 will be going there, column 4 will be coming here. Fine. So this is exactly in the same fashion like how you used to send the 0 rows at the bottom of the matrix if the 0 rows was present above any row. Similarly, this 0 column should be at the end. Okay, so finally you have got here, this is in my normal form. Okay, so this matrix is in my normal form, and fine. All numbers are zeros and ones only. All leading ones are actually right hand side to the previous leading one. Okay. And if you have any zero column, that is at the end. If you have any zero row, that is also at the bottom of the matrix. Okay. So this is my normal form. And this normal form I can write in which fashion? I can see that till here this is my I3. Fine. No. If I will consider this 3 cross 3 matrix, this is square matrix, it is nothing but I3. And after I3, you can write down this is 0 here, right? After that, this is 0. And then below also you have 0 and right, and then you have 0. So you can write down that this is in your I3 0 0 0 form. Fine. And what is the rank of the matrix? Rank of the matrix after reducing the matrix into normal form is what? You have to count the total non-zero rows. So total non-zero rows are these 3 are non-zero rows because this is your 0 row. So total 4 rows were there. 1 row is your 0 row. So total 3 non-zero rows are there. That means the rank of the matrix is 3. Fine. So this way we find the rank of the matrix by reducing into the normal form. So this is the second question. This question, so you can solve this question yourself. You can see here only that the 0 is present, right? So very first is what? You should have 1 present here. Okay. For that you are going to interchange row 2 with row 1. I got this much. Fine. No? And then what is my next focus? This is okay, this is okay. Next focus is this number. Why? Because I should have 0 here. After that my focus will be this place where I should have 0. Fine. For that we are going to perform these operations, because what my goal is? My goal is first I have to convert the matrix into REF form. Then we will be converting the matrix into normal form, and then we will be just counting the total number of non-zero rows. Fine. And that will be my rank of the matrix. So till here if we have reached, so after that what should I do? After that my focus is which number? This place. I'm not worried about this place right now. Fine. because this is my leading one. After leading one, any number is okay for me, but this is my leading one, so that is also okay. I don't have to worry about here. But after leading one, I should be having 0. So I have done some kind of transformation so that I got here 0. Similarly, I should have 0 here after leading one. So done this transformation and I got 0 here. Okay. So now if I will focus on this arrangement, okay. So then what is happening here? Can I say that this form is in my REF form? So for that I have to check below this leading one all numbers are 0, that is okay. Below this leading one all numbers are 0, that is okay. Can I say any other leading one? No, because after that I have the zeros only, okay. And if I have 0 rows, they are at the bottom of the matrix, that is also okay, fine. And this leading one is at the right hand side of my previous leading one, so all criteria are getting satisfied. So I'm going to say this matrix is in my REF form. My next goal is what? I am going to have the normal form by column transformation only, okay, no, by column transformation only, okay. So for that what I'm going to say here, that in my normal form only zeros and ones are allowed, no any other number is allowed. I can see here -3, I can see here -1, that is not allowed. Another thing is what? Now I'm going to have the column view of my matrix. So this column, this is C1, 1 and then all 0, this is okay. Even this, okay, even this C2, what I have to check? This is my leading one, fine, no? For R2, this is my leading one. Below leading one, zeros are present as per my REF form. But in my normal form, even above leading one, 0 should be present. And eventually, I can see that 0 is already present, so I don't have to do any transformation. This C2 is also in the correct form. What about my C3? In my C3, I can see that 1 minus 3, 0, 0 is present. What about this one? Is it my leading one or it should be 0? So since leading one is already present here, so this is not my leading one. Other than 1, I should be having compulsorily 0 in my row. Fine. So here I have to do some transformation which we have done so that this place will be 0. What I have done? I have done minus C1 plus C3. Fine. So right now my focus is at this place. Here instead of 1 I should be having 0. So for having 0, what I have done? 1 minus 1. So if 1 minus 1 I am doing here, so what I have to do here? Minus 0 minus 3, it will be minus 3 only, then 0 0 0 0 5. So it will be 0 minus 3 0 0. Okay. Now similarly I can see that 1 is present here. So what I can do? I can do again 1 minus 1. That means minus C1 plus C4. So it will be 0. This will be minus 1 0 0. So my equivalent matrix will look like this. Can I say that this matrix is in normal form? So still this is not in normal form because of this number, because of this number. Because other than this leading one, I should be having 0 here, I should be having 0 here. So for that, which operation I am going to perform? I am going to write down this C3 will be what? 3C2 plus C3 right here. 3C2 plus C3. Why I am doing so? Because I have to have 0 present here. So how 0 will come? So it will be if 3 into 1, right? 3 into 1 minus 3. 3 into 1 minus 3 will give you 0, and then 0 0 will be 0 only. All other places it will be 0 only. Similarly, here also I can say what? It will be your C2 plus C4. Why? Because this 1 is present here, minus 1 is present here. So 1 minus 1 will be 0, and these all other places are 0 only. Fine. So I don't have to worry about. So what is the next arrangement of numbers? So this will be as it is, C1 is as it is and C2 is as it is. Changes have been done in C3 and C4. So C3 after this operation is what? Zeros only. C4 after this operation is what? Zeros only. Okay, so I can say that this is now going to be in normal form because this is nothing but your I2. Fine, no? Because only 2 rows are having one diagonally. So till here this is my I2. Till here this is my I2. After I2 only zeros are there. I can write 0. Below I2 I have only zeros. And then below I2 this side also I have 0. So I can say that the form is I2 0 0 0. Okay. And what is the rank of the matrix? Rank of the matrix is what? You are going to count total non-zero rows. So this is non-zero row, this is non-zero row. All other rows are zero rows only. So the rank of the matrix is 2. Fine. So this way we calculate the rank of the matrix by reducing the matrix into the normal form. Okay, so if you find this class useful, please like and subscribe my channel. Thank you.